Okay, this one says to explain, with an example using a y value, why each function is many to one. So if you have the same y value, you could have more than one x value getting that y value. And usually the y value we try is 0. So try y equals 0. And this is a fairly standard way to do these questions. So if we have 0, we have x squared take 4 equals 0, which means positive 4 equals x squared, which means x equals positive 2 and x equals minus 2. So we have two values of x giving one value of y. Yeah? So if x equals 2, 2 squared take 4 is 0. If x equals minus 2, negative 2 squared take 4 is 0. Therefore, it's many to one. And if we were to graph this, and if you're ever stuck, I recommend graphing it, it's x squared take 4. And that's literally why we've graphed plenty of these. You don't have to do it accurately. You know x squared take 4 is just like a normal parabola, but it's been moved down 4 spots. And many to one means it fails the horizontal line test. Technically, the horizontal line test we just checked was that one, because we tried y equals 0. We could have done y equals minus 2, we could have done y equals 3, anything. We've just checked, and it fails the horizontal line test. Okay. Again, we're going to try for number 3, and I can't. There we go. For number 3, again, we're trying to try y equals 0. So try y equals 0. So we've got 0 equals x take 1, x plus 1. Now, this is just like when we were graphing them and we we're finding the y-intercepts. That's why I always try y equals 0 first, because finding the zeros is easy. So x take 1 equals 0, x equals 0, x plus 1 equals 0. So x equals positive 1, x equals 0, x equals minus 1. So we have 3 values of x giving one value of y. So if x equals 1, y is going to come out of 0. If x equals 0, y is going to come out of 0. If x equals negative 1, y is going to come out of 0. Therefore, many to 1. And if we wanted to sketch this quickly, and again, if this was an exam and I could sketch it quickly, then I would, just to help myself. Come on. Y and x. Then we have zeros at positive 1, 0, negative 1. And then I put my horizontal line in. Technically what we just checked was the horizontal line at 0, but you didn't have to put it at 0. We could have put it there. The problem with this one is, like, if it's not 0, we don't actually know where we turn around here. So making it 0 was the safest bet. Oh, why did I get rid of that? Come on. Yeah, checking y equals 0 is the safest bet. Come on. There we go. Cool. For question 6, it's kind of similar. And we're going to do it for all of these. I keep scoffing at this whenever I can't crop correctly, even though I crop all the time. Okay, so for this one, all you have to do is show that for any singular value of x, you only get a single value of y. Essentially, we want to make x equal whatever, like rearrange it to get x as the subject. So this x as the subject, this x as the subject, this x as the subject, this x is the subject, and show that there's only ever one answer. So like, you know, if you're square rooting stuff, you get plus minus as the answer. We're kind of showing that we're not doing that. Like showing that is a great first step. So 6a1, 3x take 1, so we've got y plus 1 equals 3x. Y plus 1 over 3 equals x. And because it doesn't matter what you chuck in for y, like -1 or -2 or 7 or 18, you'd always get different values for x. So it's 1 to 1. Okay, number 2, we've got y take 5 equals -2x. So y take 5 over -2 equals x. Then again, 1, 2, 1. Okay, y equals 8x cubed. Y on 8 equals x cubed. I didn't really need to write this question. So if we do the third root of y over 8, that gives us x. Now, because it's not a square root, we didn't need to plus minus, because if it's the minus of it cubed will come out as the minus of it again. But if it's a plus of it, if it's the positive of it, it'll come out as a positive. So like we don't get the repeats. So therefore it's 1 to 1, gosh. This one's even easier. We swap the y and x, so literally x equals 5 on y. Doesn't matter what y is, you'll always get a different value, but just ensure y cannot equal 0. 1, 2, 1. We didn't actually need to specify that y can't equal 0, but I just wanted to. Okay, for 6b, they've swapped the x and y around this time. So if I have x equals 3, y take 1, then y is going to be x plus 1 on 3, which is also 1, 2, 1. And you'll find that if these ones are 1 to 1, these ones where the x's and y's are swapped are also going to be 1 to 1. So I'm actually going to copy these. And they're technically inverses when you've got the x and y swapped. And we're going to be learning a lot about those later. So I think the reason they put this in here was to just give us a quick heads up as to what's to come later in the course.